Have you seen water or oil spilled on the road on a sunny day from a certain distance as you pass in a car? There is no water there. It's just an illusion. How do you see that? A man on a camel sees the reflected image of a distant tree and thinks that there must be water near the tree. When he gets near, he finds the water is not there and he's been deceived. How does it happen? During the day, the sand becomes hot, and the layers of air in contact with sand become hot and less dense. The upper layers are comparatively cooler and denser. A ray of light coming from the top of a tree passes from denser to rarer layers successively and gets bent away from the normal. When the angle of incidence becomes greater than the critical angle, the rays are totally internally reflected. The rider views the complete inverted image of the tree as if it were formed by reflection from a water surface. A mirage is an optical illusion due to atmospheric refraction. Atmospheric refraction is the deviation of light from a straight line as it passes through the atmosphere due to the variation in air density as a function of altitude. Have you observed the apparent wavering or flickering of objects seen through a fire? This wavering is an effect of atmospheric refraction. The hotter air is lighter than the cooler air, so the refractive index of hot air is less than that of cool air. Is the air stationary around us? No, air is not stationary. So, when we see any object through hot air, the image of the object fluctuates due to this physical condition. Can you think of some more instances of atmospheric refraction? How do stars twinkle? The light from the stars reaches our Earth after traveling a long distance. The light travels through different layers of the atmosphere. The density of air decreases with increasing altitude. When light from a star travels through different layers of the atmosphere, it bends constantly. The star appears to change its position slightly. Owing to the physical condition of the air, the light from the star varies continuously, and the amount of light entering the eye oscillates. The star appears to flicker, sometimes appears brighter, and sometimes appears fainter or dim. This accounts for the twinkling effect. You know, we are able to see the sunrise 2 minutes before the actual sunrise. You know, we are able to see the sunset 2 minutes after the actual sunset. This is also the effect of atmospheric refraction.